per acid, right? MCPBA is that thing. But anything that has this per acid functionality, the workshop the other night we had per acetic acid, I believe. Sometimes you'll see a trifluoridated version, right? But again, the main thing you're looking for is, it looks like a carboxylic acid, but there's an extra oxygen. And there's some extra kind of fancy arrow pushing thing that, can I remember how to do? No, I don't know. Where we end up now inserting the oxygen from the per acid into the alkene double bond and producing an epoxide. So these are the two main methods for synthesizing epoxides. That simplest epoxide is called ethylene oxide. And I'm saying that not because I've developed some interest in naming since you last saw me, but just to kind of remind us now that we also, if we focus on the two-step method, should be able to think mechanistically about how we might make, let's say, that which is propylene oxide. So we know we could get that from just using MCPBA. But I want us to remind ourselves what would happen first if we treat this with Br2 and H2O. From the beginning, what would happen? Like, describe it mechanistically to me.
From the bromonium ion intermediate.
Right, from a bromonium ion intermediate. And again, the way I like to think about this is that once bromine, which is nonpolar, gets too close to this pi electron system that's very electron rich, then the proximity of these pi electrons will distort the electron density of the bromine, right? So that, you know, when the bromine gets close enough, it feels like it has a partially positive there and a partial negative there, right? Because these electrons getting close to one bromine push the electron density away from it. So it sets up an induced dipole that wouldn't be there normally if it weren't in the presence of the alkene. So then this now will attack one of the bromines, kick the other bromine out. But if it were, you know, if it were to open up the pi system and make a cation, right? The cation would be next to a bromine that has lone pairs of electrons on it. So in other words, you never actually form a cation, because as it begins to open up the pi bond, electron pairs on the bromine, you know, occupy the position that would have been created. So you make first a bromonium ion. You would release Br minus as a byproduct. But if you have Br2 in water, you know, you're assuming that when you say in water, you're meaning like water is a solvent. And usually you have much more solvent molecules than you have anything else. So if the reaction is run in water, once you make the bromonium ion, then statistically it's more likely to encounter a water molecule in the right orientation than it would be to encounter a Br minus anion, right? And also remember that water, yeah, maybe that's all I want to say. Because I don't know if I want to get into which is the stronger base. Water would be the stronger base. So with water present, then I've kind of deliberately drawn that to be a bit wonky, right? If you're in a workshop last Thursday, AT was telling us things about, you know, when you protonate an epoxide and react it with something, the thing that you reacted with would attack the side where the bond to the thing would be longer and weaker. In this case, so whenever we have a pattern that we see a lot of reactions following, whenever you have a three-membered ring with a positive charge, right, the side that's more substituted is depending less on the electron pair on the bromine to stabilize any kind of partial positive that's here. Therefore, the side that's more substituted ends up, you know, feeling like it needs the bromine less because the alkyl group is already stabilizing the positive charge there. So what you find is that bond tends to be longer and weaker. So that when water comes in now as your nucleophile, that's the side that it's going to attack to make your halohydride. And if we just draw one more intermediate step. So that would be how you form the halohydride. And although I haven't been very careful about drawing the stereochemistry here, it's important to note that the OH and the Br end up anti-tuned.